Good morning, students. I welcome you all for another lecture on the course Microprocessors and Microcontrollers. In today's class, I am going to discuss about the concept protected mode operation of 80386. We all aware of that 80386 processor operates in basically two different modes. One is a real mode and second one is a protected mode. And sometimes you can also say that 80386 supports three different operating modes. One is a real mode, second one is a protected mode, and third one is virtual 86 mode. Basically, virtual 86 mode only exists in protected mode operation. So that's why here I mentioned that 80386 basically operates in two different modes. One is a real mode and second one is a protected mode. In this class, I am going to discuss about the protected mode operation of 80386. In the last lecture, I discussed about a real mode operation of 80386. In this class, I am going to discuss about the protected mode operation of 80386. Right, the first point about this is like this. All the capabilities of 80386 are available for utilization in its protected mode operation. That means what are the capabilities or 80386 has? All those capabilities are available like a protection mechanism, like a paging mechanism. All these things are available for 80386 utilization. Only that was happened in a protected mode operation. That is the meaning of a first statement. And coming to the second one, the 80386 in protected mode support all the software written for 80286 and 8086 to be executed under the control of memory management and production abilities of 80386. That means we know that in real mode our 80386 acts like a fast 86. In that real mode, it will go and execute all 8086 programs. Coming to a protected mode, we clearly mentioned that what are the programs we developed for 8086 or 80286, those programs we can go and execute on 80386 without any modification. But in the execution of those programs here, we may get additional features, that is control of memory management as well as protection abilities. All these things comes onto the picture. And coming to the third one is the protected mode allows the use of additional instructions and additional addressing modes of 80386. So once you remember friends addressing modes concept, in 80386 itself we defined a newly three different addressing modes. Those we can call as scaled indexed addressing mode. Those three addressing modes are like this: scaled indexed addressing mode, that was number one. Number two, based scaled indexed addressing mode. And number three, based scaled indexed addressing mode with displacement. These three addressing modes are newly defined in 80386. What are the instructions those are made with the help of those addressing mode? Those instructions I can go and use only in this protected mode. So that's why here I written as the protected mode allows the use of additional instructions and additional addressing modes. What are the new instructions that was defined in 80386 which are not available in 8086 or 80286? Those instructions also only used in protected mode operation of 80386. So that is the meaning of this. And coming to the next point is, in this mode, the contents of segment registers are used as selectors to address segment descriptors which contains segment limit, base address and access right bytes of segments. So here what a segment register can do, in case of protected mode operation of 80386, it is like this. These are segment registers. So the contents of the segment registers are used as selectors to address descriptors. What descriptors contains? Each and every segment has its own descriptor. that descriptor size is equal to 72 bits. In that, some of the bits are used for representation of segment limit and some of the bits are used for representation of base address of a segment and some of the bits are used for access rights of that corresponding segment. All these things are present in a segment descriptor. In order to address or point that segment descriptor, we took the help of segment registers. So that's I am writing here. In this mode, the contents of a segment register are used as selectors to address segmenters, descriptors which contains the segment limit, base address and access rights of segments. And coming to the next, the effective address is added with the segment base address to calculate a linear address. So what this effective address is? If you remember addressing most concept, I already told you in that concept, that is effective address is nothing but the final offset address. The final offset address of an operand we call as effective address. So here what we are doing is that effective address is added with segment base address in order to calculate linear address. That means if I want to access something from any segment, what I have to do is I have to go and calculate a linear address. How I can calculate this linear address is simply by adding of a segment base address with the offset address, which is a final offset address. Here that I can call as a effective address. So that's the meaning of this. This linear address is further used as a physical address if the paging unit is disabled. Otherwise, the paging unit converts the linear address into physical address. So here important thing is, whatever the linear address that is produced by the segmentation unit, that linear address sometimes we are considering as a physical address. What a physical address? Physical address means an address which is assigned to the memory locations physical. So that meaning of physical address. But the segmentation provides a linear address which is not a physical address. In your processor, the paging unit was disabled. Then what happens is whatever the linear address that will be produced by the segmentation unit, furtherly it will be considered as a physical address. Once you have a paging unit and it is enabled, then that paging unit what it does, it will convert the segmentation unit produce a linear address into physical address. That's the meaning of this. And coming to the next point, that is the paging unit is a memory management unit enabled only in a protected mode. So once you remember friends, architecture of 80386, in that one of the section is a memory management unit. In that memory management unit, again we have two subblocks. One is a segmentation unit and second one is a paging unit. So always the paging unit is under control of a segmentation unit. So here what I can say is the paging unit is no doubt it is memory management unit. It is absolutely right, and it is enabled only in protected mode. That means this paging unit was not enabled in real mode. Why? The reason for this is the real mode operation of 80386 is just like a fast 86. In case of 8086 processor, there is no chance of using a paging unit. But there we are using only segmentation unit. So coming to protected mode. In protected mode operation, what happens is your 80386 can go and use all of capabilities for utilization. So in that process, it definitely took the help of a paging unit. So this paging unit is only exists in a protected mode operation. So because of paging unit also a part of memory management unit. And next, the paging mechanism allows handling of a large segments of memory in terms of pages of 4 KB size. Generally, if you go for a segmentation concept or a paging concept, our main motto is utilization of available memory as efficient as possible. If you are coming to 80386, the segment size is too large. It is equal to nearly 4 GB. So, in order to utilize that entire segmentation space, it is somewhat too tough. In order to go and use that entire segmentation space more effectively, then we can go and use the paging concept. In this paging concept, what I try to do is, I can go and divide that segmentation into small partitions. Each partition size is equal to 4 kilobytes. Then I can go and use the available segmentation memory is a more effective way. So here that's what I'm mentioning. The paging mechanism allows handling of a large segments of memory in terms of pages of size of 4 kilobytes. And coming to the next, the paging unit operates under control of the segmentation unit. That's what I'm saying just now. And next, the paging unit, if unable, convert a linear address which is produced by a segmentation unit into a physical addresses. Only it was happening a protected mode. So because I'm already told you that this paging unit only enabled in protected mode operation of 80386. It didn't enable in case of a real mode operation of 80386. And coming to the next thing is, so this is the way how we are calculating a physical address. So physical address calculation of a protected mode without using a paging unit. So see here friends, this is a 48-bit or 32-bit pointer. So here the least significant either 16 bits or 32 bits we consider as an offset address. And then higher order 16 bits, if you got to consider the total pointer size is a 32 bit. Out of 32 bit, 16 bits we consider as an offset, and the rest of the 16 bits we consider as selector. Once you are assuming the total size of this pointer is 48 bit, if it is a 48 bit, then again coming to offset case, offset size in this particular case is equal to 32 bit. We left with another 16 bit. That 16 bit again we consider as a selector. This is selector, what it does, it guides to us to meet a segment descriptor, where I may get my segment base address as well as the segment limit as well as access right bits. So just I have discussed that one. So my segment register always provides a segment selector of size 16 bits, which guides me to go and reach a segment descriptor where I was getting my segment base address. So if I go and reach to this segment descriptor, I may get a base address that I was given to one of the input part my summer circuit, and I will get the offset address from this 48-bit or 32-bit pointer. It will do addition between an offset address and this base address, and here I was getting a linear address. This linear address is considered as a physical address once you are not having paging unit in your system. Once you are using a paging unit, then what it does, it will convert this linear address into again a physical address. Then this physical address is applied to the memory itself. And here important thing is friends, that is the total size of a segment in case of protected mode is it is equal to 4 GB. That's why what I am saying is, in order to go and use effectively this 4 GB of a segment space, I can go and take the help of pages. So paging concept I was using. There I was dividing these 4 GB of a segmented memory into number of pages. Each page size is equal to 4 kilobytes. Then I can go and use effectively the available memory space. So this is the concept of protected mode. I think everyone can understand this concept. So I hope you can understand this concept. Thank you for patient listening. We will meet in a next class. Thank you very much once again.